that, our next technical session on conformal cooling insert by binder jet 3D printing. This is by Mr. Ambresh Nagaraj, team leader, Indo-MIM. May I please?
Good afternoon, everyone. My name is Ambresh Nagaraj. My education background is I completed my tool engineering from NTTF in 2014. So, in 2014, and after my post-graduation studies, I started my career at Indo-MIM since 2014. And currently, I'm working as a team leader, and I'm handling additive manufacturing projects. So, and I'm happy for giving this presentation in front of my NTTF gurus. So, and also, I'm thankful to Tagma team for giving me this opportunity. So firstly, about Indo-MIM. So we, Indo-MIM, are the manufacturers of small, complex, precise components. So we make through a technology called MIM, metal injection molding. So, and we are one of the world's largest manufacturers of MIM parts. So we manufacture and supply MIM parts to various countries like USA, European countries, and also the Asian continents. And we service almost 650 plus customers globally, and we ship almost more than 150 million parts per annum. So these are our manufacturing footprints. So we have facility, two plants at Bangalore. One is at Dodbalapur, and one is at Oskote. And we also have the investment casting facility at Tirupati plant. And we also have the two manufacturing facilities at USA. So one plant is for manufacturing of MIM, and the other one is investment casting. So these are our capabilities to address the market. So we offer parts through metal injection molding, ceramic injection molding, so investment casting, and aerospace machining as well. So aerospace machining, so normally we do a bar root method. And we also manufacturers of metal powders for additive manufacturing and also for MIM process. So we have two different types of atomizers. So we have a capacity of almost 1,200 tons of metal powders. And we also have the capacity of additive manufacturing process. So we have the binder jet 3D printing technology and also the LPBF. So these are the contents that which we wanted to discuss on this session. So since we have less time, like I just wanted to brief on the binder jet 3D printing technology and why Indo-MIM is focusing mainly on the binder jet 3D printing technology and what are its benefits. So about binder jet 3D printing technology. So binder jetting is a family of additive manufacturing process. So in this process, normally we use liquid binders as a bonding agent. So these liquid binders actually with jets onto the powder bed, which percolates into the powder and it creates a solid part. So these, the solid parts, then we will take into the next process like a debinding and sintering process. So that the process, I'll take you to the next slide. I'll explain you about the process. And the beauty of this technology is we can process any different types of materials. That means like we don't have any constraints on the metal powders. So we can also use process through ceramic powders, and also we can also use sand printing as well. So this is actually the process. The first 2 points are the powders spreading and the printing. So first 2 are the printing process. So normally like we use the gas atomized powders for the process. So these gas atomized powders will help us on the powder flowability. And the next is the printing process. Here the binders will jet selectively upon the part profile area. So where the binders percolate into the powder particles, which holds the powder particles together just to give a shape of the product. So once after the 3D printing process, so these binders normally requires curing. So because these are the thermoset binders, which requires thermosetting to give the good green strength. So after 3D printing process, like the entire build box, we will keep it for the oven, which we will heat to 150 degrees for 5 hours, so which gives the enough green strength. So after the oven, the curing process, we do the depowdering. So that means we will take out the green parts. So after printing, we will take out the green parts and we will take it for the sintering process. And these powders can be reusable multiple times. So there is no wastage of powder in this process. And after taking the green parts, we will take into the sintering process. So where these binders we will decompose into the sintering process, and it will give the shape. Like the powders, it will get fused together and give the final shape. If you look at the process of MIM and the 3D printing process, so just if you see the injection molding process in MIM, just replacing the injection molding is replaced by the 3D printing process. The rest of the process will be same as like for a MIM process. So definitely, like what the advantage we are getting if we go through binder jet 3D printing route. So definitely, people may ask like why binder jetting is required. So the MIM process is extremely cost competitive. So definitely yes. So definitely yes, but so when we have the high volume production, then definitely it is a cost is quite competitive. Suppose if the volumes are like less than 5,000 pieces or 2,000 pieces, so the MIM process is not competitive. So because the tooling cost will directly impact onto the part price. So hence, we always suggest to our customers for any low volume parts, less than 2,000 or 5,000 pieces, we will process to go through 3D printing technology. And secondly, for any high volume parts, before it goes to the production level, so normally customer used to ask for some samplings of 500 or 1,000 pieces for the testing and validation process. So here, earlier, we used to go for a proto molds for molding 1,000 or 2,000 samples. But now we are completely skipping this proto sampling, and now we are submitting the samples through binder jetting 3D printing route. So because the advantage is, since we are using whatever the powders which we are using for the MIM process, the same powders and the same sintering profile we are using for binder jet 3D printing process. So hence we are submitting the samples within 2 to 3 weeks time with the binder jet 3D printing route. And one more advantage is if any complex shapes, like if we go through a tooling application, so definitely we have a constraint in tooling. So higher the complex the part, definitely we will get a lot of intricate shapes. So all this, the complex shape of parts, so directly we are taking into 3D printing route. So and again, so why binder jet samples the samples we need to submit through only the binder jet. So why not through laser print bed? So definitely, as I told, since we are using the same powders and the binders, so we do get the same metallurgical and mechanical properties that what we get in MIM. So that is the reason we are submitting the samples to customer. So where the customers can take the samples for any initial validation and they can finalize the products to the high volume production through multi-cavity tools. They'll come for the MIM route. And again, when we see the speed of the laser bed and the binder jet 3D printing technology, the speed is almost 5x times faster than LPBF. So because irrespective of the part profile, the binder will jets at a time with one go. So hence each layer, the time taking for printing it's take less time. So hence the speed is very less. And as I told, we use MIM powders, so which is very cheaper than laser bed. So this is one more advantage which we are getting. And one more thing, as you know, with the LPBF process, for printing any intricated or overhanging parts, so definitely we require a supports. But whereas in this technology, so we don't require any support generation. So the loose powder will itself will act as a support, and we don't require any secondary process after finishing. And the binder jet tolerances are, which is shown. So the tolerances are like plus minus 1%, and in future definitely like we are working with different powders, so which we will target with plus minus 0.75 degree. And also the drawback as of now we are getting is the surface finish. So right now the surface finish we are getting is 2 to 3 RA. So definitely which is not good enough for even for the sample submission. So definitely we are working on some powders. So definitely we will try to achieve the tolerance with 2 to 3 RA. And currently the powders are in the basket. So we are processing SS316, 174, 310, M2 tool steels, the tungsten carbide as well. So as I told, like with this binder jet 3D printing technology, so we can process any types of materials. Means there is no constraint on materials. So any powders that can be sinterable, so can be easily processed with this technology. And also like we are working on several materials like S7 4605, SS420, so Inconel. And also the advantage what we have is we have in-house powder plant, so we can tweak the chemistry and we can work with different developmental projects, and we are also okay to give the samples to the customers within less lead time. So this is one of the example printed parts. So as I told, so the part is printed in the green condition. So as we told, like, the parts in green condition means it's a combination of the powders and the binders. And after sintering process, we will retain the shape during the sintering process. So here, this part actually does not require any support structure. So, and these are some of the engineering samples. So the main, we need to work on this. So we need to work on the shrinkage factors. So as we all know, like during MIM or binder jetting process, so we scale up the model by 20% higher, because we are adding the binders into the powder, so which increases the part size. So during the sintering process, like we will take out all the binders, it retains its shape back. So therefore, like we add the shrinkage during the printing process or during MIM process. So these are the samples which we already shipped to our customers. As we told, like initial samplings and all, we are shipping through this technology for the low volumes. And this is one phase of it. So directly we are shipping the samples through binder jet 3D printing. And this is second phase, the tooling application. So as we all know, for any for manufacturing any MIM part, so we required a tool. So definitely, the selection of the tool steel for metal injection molding process, so definitely it is a critical role. So because, so as we know, like the feedstock that MIM contains the metal powders, so which wear out the faster. That means the tool life will be very less when we go with the tool steels, which is having with the existing tool steels. So currently we are using M2 tool steels, which is giving the very good, the tool life. When it comes to the cooling lines, so as we know, like the cooling lines will play a major role for getting the better part quality and the tool life. So we at Indo-MIM using conformal cooling channels since 2015, so which is increasing the part quality in terms of part quality and also the cycle time reductions. But existing the tools, so we used to do with a maraging tool steel, so where we used to get the tool life which is very shorter, so where the tools has to wear out faster, less than 1 lakh shots. but we are quite unhappy with the tool life. So we wanted to implement M2 tool steels with the LPBF process. But as we know, we cannot process the high carbon tool steels through LPBF, and now we are processing the conformal cooled tool inserts through a technology called binder-jet 3D printing process. And now for all in-house tool inserts, we are manufacturing the conformal cooled tools using M2 material. So right now with the M2 tool steel, we are getting very good tool life. So the advantage of the M2 tool steels, so right now, we are printing the core or cavity nearly to the net shape just by adding a stock of 0.2 to 0.3 mm. So then we will finish it for the final process by either wide iridium process or the sparking process. So because actually, as we know, this M2 tool steels has high wear resistance, so which holds the cutting edges. It's very good because of its fine microstructure. And also the hardness, what we get is 64 to 66 HRC. So because, as we told, our feedstock is quite abrasive in nature, so it's wear out faster with other materials, whereas with M2, we are getting almost tool life more than 6 lakh shots. But almost 6 lakh shots we completed, still the tools are under monitoring process. We need to see up to what, the tool life which we can expect through this M2 binder-jet process. And actually, this is the wear resistance. We taken the trial with the pin on disc. So here, the lesser the mass, the better the wear resistance. If you see the first two, which earlier we used to use the conformal tool inserts with the maraging steel, and the second one is the wrought inserts, which we already doing with our conventional way, and the third one is the binder-jet M2. So if you see the wear loss, so we are getting a very good wear resistance. So then we would like to we started this M2 tool steels using with our in-house mold inserts. So this is the metallurgical properties. So if you see the density carbon, so we are getting almost 99% of density with the controlled carbon. And if you see the microstructure after heat treatment process, so here, if you the microstructures are very fine, so which which is giving better tool life. So, and also if you see the machinability in terms of rod to BJT, so we are getting very good the tooling, increasing the tooling life because of the chemistry that what you are using for M2. And here at Indo-MIM, so because of this advantage, so we procured a production machine, so which we are 40% of the tooling capacity we are doing for conformal cooling inserts. So it means the critical tools of 30% of tools, so we are manufacturing through this binder-jet 3D printing technology. And some of the case studies what we got a very good results from conformal cooling. So this is one of the customer, the automotive part. So we have the blind hole sink. So with the existing cooling lines, we used to get almost 60% of blind sink. So if you see the cooling lines with the existing and the conformal cooling, so after implementing the conformal cooling channels, so we eliminated the sink and other molding issues. So as we know, the MIM process or the binder jetting, the MIM process, it's a multiple process. So if we get any defects in the green stage, so during sintering process, it will affect more. So that's what we always try to focus for getting the green parts or molded parts with a good part quality. So otherwise, it is going to affect more in sintering process. And here again, the second case study is one of the automotive part. So we used to get the sink issues with the existing. Almost we used to get a 30% of rejection in the green stage. So the conventional cooling, we used to get a rejection with due to sink issues. So that will affect the cracking during sintering process. So we implemented the conformal cooling channels with the critical areas like this. So we are eliminating almost the issues like this. And this is one of the good case study. This is one of the defense part. So if you see the part profile, the slot, so here normally the coolings which goes, we used to get a sink issues. So we do get a lot of distortions here. If you see the cooling lines, because of the distortion, we used to add a coining process to get the slot back to the original position to get the customer requirement. So after implementing the conformal cooling channels, so we are getting less distortion in the green stage, so which we are getting better distortion after sintering. So with this way, like we are eliminating the process like coining process. So it means like the conformal cooling channels, it is helping a lot in different secondary operations like this. And this is a similar case study, which is a defense part again. In this slot, actually, we used to get a distortion. So where with adding, with the existing cooling channel slide, we could not able to give the cooling channels because of the size constraint. So with the conformal cooling, we could able to give the cooling lines with a low wall thickness as well. So with this, we completely eliminated the distortion and we skipped the coining process. And this is one more case study which we used to face. This is a defense part. The one which is highlighted is the aesthetic area. So there we used to face a lot of sink issues, 100% sink. So after printing process, sintering process, we used to go for a buffing process just to eliminate the sink issue. So after implementing this conformal cooling channels, so we are getting 100% without any sink issues, where we completely eliminated the buffing process. So this conformal cooling channels like this, for most of the critical parts in the MIM process, we are trying to eliminate the molding defects, and it is improving our process capabilities. So about Indo-MIM, like we are the trusted partners. So we have 25 years of innovation experience, complexity simplified, and we are flexible to customize, and we are open to the market for any new development, powders, or the 3D printing proto sample activities. Thank you.
Here with us and for that wonderful presentation.